This is an overview of what you can do combining scraping with LLMs. I'll try not to bore you with code and even show a way to fetch data just with a query. We'll cover why to use an LLM to scrape, which websites can we scrape, then we'll go from the easiest way to scrape a website with AI all the way to the harder yet cheapest option, which is running the LLM locally. In my previous video, I've received many comments asking why use an LLM to scrape if we can just use normal Selenium, Beautiful Soup, or Puppeteer. So let's settle that right here from the start. Crawling systematically discovers and navigates web pages. Scraping extracts specific data from those pages. If you want to fetch data from a specific website, the structure of those pages hardly ever change, and you know basic coding, then don't use an LLM, just code it. Because in this scenario, you already know how to get your crawler to where it needs to be. The issue is that we want to build more intelligent agents for many different tasks. One task could be get me news articles only about AI agents. Without an LLM, the crawler would have to fetch you everything, or fetch based on keywords or tags. It's programmatic. The idea of using an LLM is that while crawling, it already understands its tasks and navigates a website in search of that specific query. I'd say 90% of today's needs can be solved just with simple old scraping. But the more technology evolves, the more these needs change, and using AI for this may be an interesting way to go. If you want to learn more, check out HasData's article on this. It covers pretty much everything you need to know. Now, let's be careful. Don't scrape everything. Some of you asked about scraping YouTube, X, and Instagram, but they do place blockers to avoid it. And while some folks over at Reddit confirm it's possible, I would much prefer using their APIs to get the same data, but in a legal way. For some websites, you can just check their robots.txt. They will specifically instruct you about what they don't want being scraped. Now, the absolute easiest way to scrape a website is just using Firecrawl's new extract feature. You type in a query, place in the website's name, so in this example, from firecrawl.dev, get the pricing. Try for free. That will automatically create the parameters. So these parameters are basically get the pricing and also the name of the website. So firecrawl.dev, and then it already scrapes the website, like crawls the website in search of the actual domain on which you can find whatever you want to find from this prompt. The prompt is improved also. So extract the pricing information from firecrawl.dev, including plan names, prices, and features for each plan. When I hit run, it does its job. So scraping, crawling, whatever it needs to do, then it returns a structured JSON for us. The first pricing here is free, so you can scrape up to 500 pages in this free plan. And if you ever consider upgrading, let's hit pricing, go over to price, hobby, subscribe now. You can use my promo code Leo10 to get 10% off. So just typing Leo10 here, hit apply, and you'll get that 10% off discount. Let's try a more advanced approach now. It involves coding, but I promise you it's fairly easy. I've placed together two examples using Crawl4ai, since it's the top one repository on GitHub focused on LLM scraping. The first one is a knowledge graph generator. For those confused on what a knowledge graph is and why it even matters, well, normally we use vector databases to find things for LLMs, since it uses cousin similarity to gather the closest documents to a given query. A rough example would be, if I ask, who's Leo's uncle? It would find all the documents that's similar to this string, then return them to me. So because of this, it could fail to find who's my actual uncle. But with knowledge graph, we have objects represented as nodes with relationships between them. So if I ask the same question, I'd get, Leo has a parent who has a sibling, and that sibling is Leo's uncle. I'm using OpenAI's GPT-4o Mini for this example, as you can see. Then you have the rest of the implementation down here, and what you need to understand about Crawl4ai is that everything runs around this specific crawler and everything you insert inside of it. So for the configuration, I'll specify the crawling configs, and not necessarily do you have to use an LLM strategy. It also crawls a website without using the LLM, then it brings it back to you in a structured way. But the idea of using an LLM is just getting everything done as you crawl, as you scrape. And this is what is specified right here. So in our LLM strategy, I specify the provider, I give the OpenAI API key, then I specify this schema. And this schema is oriented towards building the knowledge graph. So the extraction type has to be a schema, and then the instruction, which is basically our prompt, is extract entities and relationships from the content. Return a valid JSON. Depending on which model you're using, you'll have to reinforce this return valid JSON, or and sometimes even specify how you should build this actual agents. A better LLMs, like if I were using GPT-4o or Claude Sonnet 3.5, I wouldn't have this issue. I wouldn't even need to say return a valid JSON. Now comes a more interesting part about Crawl4ai. So in some cases, we want to scrape a really large file. And there are some problems scraping that because it can be larger than the context window of the specific LLM we're using. And also we can remove this from Crawl4ai. So in this specific example right here, you'll see that for the crawl config, I include tags, form, header, and footer simply because I won't use them. But sometimes the text is actually just really large, and even removing these HTML tags won't be enough. That's where chunking comes in, and you get this integrated already in Crawl4ai. So what it does is basically, if I tell it, look, I'm looking for this specific link. The link is to the contributors page. So what it will do is understand, okay, the user is looking for this. So it'll get the first chunks of text from the page, check if it has the context or the link I'm looking for. And if it does, then it just stops scraping that specific website, because this way it makes it cheaper for you because you're not sending the entire page over to the LLM. If it doesn't find it, then it'll go to the next chunk and the next chunk. And like it works through these blocks of text to find whatever you need. And as soon as it does, then it goes on and does whatever you need it to do with that information. Okay, with that said, let's see what we're scraping. We're going to scrape this entire page. So it's the classes page for the Python documentation. You'll see that it has a lot of different terms: method objects, class objects, the class itself, class definition, syntax. And what if I wanted to know like the relation between all of these different terms? And that's where our knowledge graph comes in. So I'll just rename this to KB result 1. All we're going to do here is just execute this. So Python knowledge graph. Okay, just executed it. Now you'll see it scraping the page. So first thing, it accesses the page, and then you'll see like multiple times it calling OpenAI. And why is that? Because it's going through each chunk, going through each block of the page, so it doesn't send everything and blows the context window. Okay, that was successfully done. And then I get like the tokens usage summary. That's because I placed, let's see, where did I place the configuration to show that? Yeah, LLM strat show usage. This is pretty helpful for you to understand how much you're spending. This was generated, so kb underline result.json. As you can see, there are name, description, and this describes the relationships between them. We're going to use Neo4j to visualize this. And since Neo4j can't read direct JSON, I built a code. And obviously, this could have had a much better way to be done. But I simply generate the Cypher query by executing this code. Okay, so Python convert to Cypher. And yeah, this is the code. Obviously, use Claude to produce it. It just gets the KB result JSON. Now with this text, all I do is copy it, go over to Neo4j, type it in there, hit play. Now everything is sent. Now all you have to do is type in something that I always forget. So it's match n, return n. Yeah, it's just that. And you can visualize all the like entities and the nodes. Let's just make this bigger. And really, this isn't a Neo4j tutorial, so I won't go really in depth on how to set this up, but it's really an interesting way for you guys to get an idea of what can be done when scraping with an LLM. Now, my second example is the crawl commands.py. This is really just a simple example I wanted to show you guys on how you could just specify a website such as crawl4ai.com. It's already open here. And then by using these commands, you'll loop. What I'm doing here is just looping through a function that does the crawling and the extraction. And on the first execution, it should find the link to the GitHub repository in the content. Return only the URL. Why should it return only the URL? Because I only want the URL to be inserted inside the function when it's executed right here. And then it will go to that page, find the contributors.md, return only this URL. Yeah, and I just noticed I wrote return only the URL twice. I guess I really wanted it to return the URL. Yeah, and then we will get to the contributors.md. And only inside that page do I want it to extract the name of all the contributors from the content, return only the names in a comma separated list. So it is a dumb example because the changelog is right here, and this changelog directs us over to GitHub, and inside GitHub, it redirects us to contributors.md. So if I were producing something that I knew every time just had to go to this contributors tab, then I would just use directly this website. So it's really just an example to show you guys how it can crawl from one page, access the other, and then get the content from the last page. So yeah, let's just execute this. The first thing it does is come to Crawl4ai. In here, it'll find the changelog. As soon as it does, and it does that pretty fast because it's one of the first things here, it goes on to the changelog markdown in GitHub, and now it starts going through each one of these blocks. And for you guys to understand this better, it's like if it came over to this view source. And if you search for contributors here, you'll see that it's only in the middle of the page. And there are a lot of tags here, like these meta tags, that could be removed from like up here. We could remove them just like we're removing forms, header, or footers, because that ensures that the LLM gets where we want it to get much faster. But I've noticed I got an error right here. That's because the URL crawled was Crawl4ai open source LLM friendly web crawler and scraper. This isn't a URL, so it tried fetching that URL and then got an error. I should have an error exception for this, but the main problem is in the LLM. So if I just remove this and use a way better LLM, you'll see the results are better. And this is basically because of structure. I feel that the more smarter a LLM is, the more it understands structures and understands like what it should be fetching and like agentic prompts, right? So it's doing it all over again, but now using GPT-4o. Okay, so now it finally found the URL. This is the URL. It's correct. Found the URL and then got the content back to us. So this content is well structured into the core team. Then you get the content, which is Uncle Code, Nazrin, and then it lists the community contributors, which are these, and then for the pull requests, yeah, you got the idea. But the point is, using a LLM to extract data from a website when you're expecting some structure relies on having a pretty good LLM, or just really prompting it better. But since sometimes we don't know exactly where to look, or we don't know a structure of a page, we can't really provide the best prompting possible. And then because of that, we end up relying on the LLMs. I'm explaining this because a lot of people argue that we could just use a local LLM to extract data. And it's not that easy because the local LLMs, as you'll see right now, aren't so optimal. The same DeepSeek that you use in their website or from the API isn't the DeepSeek that you use on your local computer, but you can potentially get some things done with it. So let me first open up Ollama serve. Yeah, now it's executing it. Let's change this provider from OpenAI over to DeepSeek. I'm not going to use the 32B because, or else we'll stay here forever just waiting for it to respond. I can then remove the API token, and as soon as that is set up, erase this and start the knowledge graph. Let's rename this to 2, execute this, and see how a local LLM will perform in this specific task. Yeah, it took a while, but now it's responding, it's solving some calls. I think it might have already fetched it. It's just now the LLM is actually working on producing the structure. Let's take a look at it. Okay. Yeah, so it brought a pretty nice structure, and that structure is really guaranteed because of this schema that we input right here. Let's compare this to what was created previously. So right off the bat, you can see that some entities weren't discovered, as well as some relationships. So for the JSON output of GPT-4o mini, this was what was generated. And then for the local Ollama DeepSeek, this one was generated. And here's the point, because if you want to do this one single time, if you're going to do this only one time, you could just test this 32B, so Ollama list, you'll see that I have the 32B here installed, but it's like 4 times the size of the 8B. And yeah, I would expect that this would produce a way better result than this one. The issue with running a local LLM is that people tend to think it's free. And it kind of is depending on your usage, but eventually as your project gets more users or features, you'll have to upgrade either to having a server hosting your LLM, which will certainly cost you something, or to simply going for an outsource like OpenAI or DeepSeek or Claude. That is it for today, guys. Thanks for watching, and I'll see you in the next video. Till then.